Okay, so I want to start today's lesson by actually talking about a topic that we've studied for a lot of the year, but now we want to talk about it in the context of polynomials. So we're going to start by talking about the distributive property, which of course we've studied before. Okay, so when we're talking about the distributive property right now, we're going to talk about one term on the outside of the parentheses, right? So yesterday we defined, if we had a polynomial with one term, we call that a monomial. Okay. And we're going to multiply that by something else, right? So in this case, it's two terms, right? X is a term and 8's a term. So that's a binomial. Okay. Or we might have a monomial on the outside multiplied by a trinomial. Okay, because this last one has three terms. Okay, so just understand that today we're just talking about when we have a monomial, when we have one term only on the outside. Okay, so let's get rid of some of that, and now we'll look at some examples. Okay, so I'm going to introduce a new way of actually doing the distribution. It's going to be something called an area model. Okay, so the area model, we're going to make a rectangle. Okay. And here, on the left side, we're going to put our term here, our monomial. So that's going to be a 4 here. Okay? And then the right side here, we want to split for each term. So we want an x here and a -8 here. Okay? So quickly, we can do, now we're going to multiply, right? Because to find area, we multiply width by length. So this is 4x. Right, 4 times x is just 4x, and 4 times -8 is -32. Okay, so that simplifies to 4x take away 32. Right, and of course we can use our regular distribution method. Okay, where we take our expression and we multiply the outside term by each of the inside terms. Sorry about that. So 4 times x, again, just 4x. 4 times -8 is -32. Okay, so the area model is just a new way of looking at it that may help us stay a little bit more organized. If it's not something you like, I don't expect you to use it. Really quickly, let's look at this next example. So now, when I make my area model, right, since I have a trinomial inside the parentheses, I'm going to need to break this into 3 boxes. So I'm going to put a 3x here, okay, and x squared, -3x, and a 5, okay. Positive 5, so it's just going to be a 5. One thing to keep in mind, here I'm really talking about 3x to the first power and -3x to the first power, okay, so let's include that down here. If that helps us out. So now I have 3x to the first times x squared. Let's change the color real quick. So when we're talking about multiplying, right, we can multiply these even though they're not like terms. We can multiply anything. So the 3 stays, right? X to the first times x to the second. So if I think back to the last couple days here, when I'm multiplying exponents with the same base, I add the powers. So I get x to the third. Okay. When I have now I have 3 times -3, which is of course -9. Okay. X to the first times x to the first, I'm going to add up 1 and 1 and get 2. Okay. And the last one's fairly straightforward. 3x times 5 is 15, and just with an x. So I have 3x to the third. Take away 9x squared plus 15x. Okay, and I can't simplify any further because I don't have any like terms to combine now that I'm adding and subtracting. Okay, and we'll quickly set this one up. 3x times x squared minus 3x plus 5. Okay, and I'm just taking my 3x and distributing it to each of the terms inside the parentheses. So 3x to the third, take away 9 x squared plus 15x. Okay? So what I want you to do, if the person covering the class could actually pause the video for a second, I want everybody to go ahead and take 1 minute to try this last example, then we'll go over it together. Okay, so now that you've had a chance to try the example, let's actually go through it together. I'll start with an area model. Okay. So with my monomial on the outside, I only need one space here. And since I have a binomial on the inside, I'm going to set that up. All right, so now we just have to be careful about our multiplication. X to the third times x squared is x to the fifth, right? Because I'm going to add up my 3 and my 2. Negative 5 times x to the third, let's not make that any harder than it has to be. Just leaves me with that. X to the fifth minus 5x to the third. Okay. In the interest of time, I'm not actually going to show the distribution, but basically all you would need to do after we get back to our screen is we would we would distribute the x to the third to each of those terms. So you should be able to use these examples to complete set 1 in your packets. Go ahead and do that now.